All right, so how about some science here? Now, we have different things. This is similar to the video I made before, but we're going to talk a little bit more about it. So I have soft scrub with bleach diluted in some water. I have cream of tartar, some of it dissolved. Baking soda, again, some dissolved, some did not. We have borax, some dissolved, some did not. Okay, so these would then be saturated solutions because no more of the solute can dissolve. Tums, same thing. And then vinegar, which is just acetic acid dissolved in water. All right, so we're gonna put a little bit in each container, carefully because I don't want to stain my clothes or anything like that. Okay. All right. Notice how I'm putting, I should be labeling my secondary jars, but I'm not doing that at the moment, so I'm making sure they stay behind the jar that has the source material. So I know this is borax because it's in front of the borax jar. Smells pretty like Tums. And one note here, if you ever have to smell something in a lab, don't stick it right under your nose because then you inhale full force whatever it is. If it's an acid or a base or something toxic, it can really damage your nose or your respiratory system. So what you do is you waft the smell towards you. And believe me, right now, yeah, I can smell that this is definitely vinegar. So this is the cabbage juice. Open that up. Mason jars are basically like the country person's beaker. All right, so we're gonna set that up. Okay. Notice that it is a purple color. Okay, so we're gonna add some to the soft scrub. All right, and we see that it begins turning green. Okay, so add a little bit more, and it definitely, it's like green, maybe a green yellow. All right, now I'm able to use the same pipette because this pipette is only going into the cabbage juice, okay, the red cabbage juice. If I was putting it in the samples, then I'd have to use a different pipette for each sample, and I could never put the sample pipette into the juice, right? And so this is the cream of tartar. I'll put some in there, and we'll swirl it. This is a technical, scientific technique called swirling. Seriously, that's what it's called. That turned a nice pink color. Look at that. All right. And here we have baking soda. Oh, look at that. It turned blue. Okay. And then borax. Put some in there. I can't really. All right. That just kind of looks purple. It's not. Now, if we compare these, okay, it's not the same purple. It's a little more, I would say reddish, a little more reddish. All right, and then Tums, remember Tums are an antacid. And the water itself is colored because there were coloring in the Tums, so this may not work. When I made the video before, I had white Tums that were mint flavored. Again, it maybe is a slightly different purple, but I don't see a lot of difference there. Let's try this. I'm gonna shake this up and pour some in and see if that makes a difference. I think it's just gonna look creamy, but we'll see. Yeah, I don't. So fruit flavored Tums may not be best for this. I'll add a little bit more just to see. So I do think something's happening there, but I think the coloring and the insoluble parts are hampering our investigation. All right, and lastly, vinegar. All right, and again, we see that makes a very nice pinkish red. Okay, I like that. All right, so now if we had to organize our results, well, let's see here. We have a red, that's the vinegar. We have cream of tartar, which is also interesting. I'm gonna set the Tums aside for now because it didn't, I mean, it kind of looks bluish, so maybe we can use that. All right, and then we have the borax, and then it looks like we kind of have the baking soda, and I'm gonna put the Tums over here, and we have the soft scrub. All right, so we kind of have from a red to a blue to a green. Let's do one more thing to see what's going on here. All right, so here I have pH paper. This pH paper goes from a pH of 1 to a pH of 12. Now the whole pH scale goes from 0 to 14, okay? And as you can see, we have reds starting with 1, and then they go to oranges, and then we get some yellows and some greens, and we get some purples. Now, different indicators use different color scales because that's just the way the chemicals react. An indicator is something that when it reacts with an acid or a base, it changes color. Red cabbage juice is an indicator. All right, now with pH paper, it's very important. You want to touch it as little as possible. And the reason you want to touch it as little as possible because your skin has a pH. The oils and stuff on it, and things you touch throughout the day affect that pH. And you want to test the pH of your substance, not the pH of your fingers. So I'm trying to hold it by the glue at the back. I'm going to peel off a piece here, and well, I'm going to try to get a piece here. All right, so I'm holding it just barely, and I'm going to dip it into, this is the vinegar. All right, so we just dip it in, and we take it out, and we see that it has turned red. All right, so we look at the pH scale here. Hopefully you can see this at home. And oh, there we go. So that's a pH of 3. Now, don't freak out. Vinegar is not gonna like eat your face off, but it is kind of a strong-ish acid. On the pH scale, each number represents 10 times. So a 1 is 10 times stronger than a 2, and a 2 is 10 times stronger than a 3, okay? Or a 3 is 10 times weaker than a 2, or it's 100 times weaker than a 1, okay? So we have identified, because we know everything from 1 to 6.9, or anything less than a 7, whichever way you want to look at it, anything less than a 7 is an acid, so vinegar is an acid. Being very careful to touch it as little as possible. This is the cream of tartar. All right. So it is also changing color. And it looks like it might be somewhere between a 3 and a 4. Maybe a little closer to a 4. Hope y'all can see that. But so it's an acid. It's not as strong as the vinegar, but it is an acid. So we have the borax. Whoa, buddy, look at that. That is a change. All right, so that measures up. That's somewhere around a 9 on the pH scale for this paper. And so anything more than 7 is a base, okay? It's alkaline. So borax is definitely a basic solution. There you go. All right. This will be the baking soda. All right, so this one kind of lines up with an 8. Yeah, this is like an 8. So this is a weaker base than borax. So I'm actually going to switch them because here's the thing. In the middle, all right, so far, this is our middle. We have acids over here. So this is 0 to 6.9 over here. We have 7 in the middle. 7 is neutral, okay? I do not have a neutral thing to test at the moment, but 7 is neutral, so it's not an acid or a base. Anything more than 7, so 7.1 to 14, is a base, right? And the closer you are to 7, the weaker you are. And because think about that. If you're close to neutral, then you're almost not an acid or almost not an base or a base. So if you so if you get farther from base, then you're a stronger acid or a stronger base as you get farther. So since baking soda is the weaker of these two bases, I'm going to put it closer to neutral. All right, now the Tums. I'm going to try the Tums. Remember, we weren't sure if we were really getting an indication here. I think maybe there's a little bit of a color change there, but I think that's actually fairly close to neutral. It might be just slightly one way or the other, but 7 is this kind of yellow color, and then as you get more and more base with the pH paper, you get more and more blue-green, all right? And you get more and more yellow-red as you become more acidic. So I think actually the Tums is pretty neutral. So here's the thing. Tums is an antacid. It is meant to neutralize acids. So even though tap water, which is what would be in these, is slightly acidic because anytime carbon dioxide dissolves in water, it forms carbonic acid. Now, not only does carbonic acid add a little bit of bite to your soda, but it also carves out over millions of years things like, I don't know, canyons, like the Grand Canyon and caverns. And if you've ever gone to the caverns where you go underground and there's stalagmites and stalactites, those were called carved out, by running water. Okay? And the running water had dissolved carbon dioxide in it. Okay? And that formed carbonic acid and helped dissolve and break down and weather the rock. All right, so lastly, we have soft scrub. Now remember, this one became very green very quickly. All right, so I'm gonna dip that in there, and oh, look at that. That is a pretty blue, isn't it? All right, so let's compare here. And that to me looks like about an 11. Okay, maybe somewhere between 10 and 11, but it's definitely a base, and it's the strongest base out of all of these. So that's the pH scale. Okay, acids, neutral in the middle, and bases.